All right. First, okay, K-means algorithms. K-means. For clustering, although there are many algorithms developed for us to use, some of those are discussed in my textbook. And then K-means algorithms, the source code was available in the textbook for both R and Python. So we're going to use those. Okay. For uh, let's see here. Yeah, K-means algorithms using all. I'm going to bring up here. Okay. Um, we're going to use the same the file, mortgage loan file, for you to recall. Here is a CSV files. It runs on Excel programs. Same one that we did for clustering. I mean classifications. Okay. All right. Yes, it's slow. So we're not going to use this the label column. Okay, we're going to use only maybe yeah, few columns, not including this labels. Okay, the clustering doesn't need labels, predefined labels. So we're going to use only paycheck, uh, the bank balance, and credits. Three columns only. So page, paycheck, bank balance, and credit. Three lines only, three columns only. Uh, Ignore the last two columns. The way that we need to do is uh, read the data. We call it data. So read.csv functions. This function takes the location of that file, and then if this file contains header, then we say head equals t. T means true, and then separator is a comma. So actual file itself is a comma. This is a better visualization. But if you read this file using, for example, open, is there open with, or here, open with, notepad, then you can see it is nothing but comma separated values. This is comma separated values. Okay. This CSV files are rendered very nicely on the Excel files. So the source file of this is this text files. Okay, as you can see. So we select only those three columns. So data, from this data, we select only those three columns. We call that selected data. So data selected, data S. Okay, and then we simply this is the visualization. So forget about this visualization. Although I showed to you how it is visualized, we don't learn much about this visualization. If you are interested in, you can include this library, okay, ggplot library. And then real clustering is this data cluster. We use a k-means algorithm. This takes the data, which is um, data S. Data S is this, okay? Everything about data S. And then there's a number of a cluster. If you want to use 3 clusters, then you can say 3, 2, or 4, whatever the number that you are interested in. This is a start number of element in that cluster. We put 20, but it doesn't matter. You can put number 2, okay? At least 2 or at least 1. I want to if I want to make 3 clusters, I want to have at least 1 element in each cluster. Start with 1 elements, then we can put 1. Okay. So save it, and the way that we can run this is using a command line. So Windows button and all, then there is this CMD open. So I need to minimize this a little bit, and then this file is located in the same directory as this. So we need to change this to a place, back, uh, data science, PY, coding, and clustering all. There we have, for example, CSV file. That's what we have this mortgage loan CSV. And then all files, here, PIR star, all. I'm going to use this k-means cluster to mortgage one.r. The command that we open up all is all script, followed by the R source file. So k means cluster to mortgage mortgage. Okay. So hit enter. Then it'll read this. Let's try first. Let's see. Oh, here. After we extract the data about those 3 columns, then I want to print data S. So we'll see data S here. We do not want to see the header. Okay, we don't need. And then this. So this is good. Go. And let me go ahead, hit enter. Okay, these are the data that we extracted about those 3 columns: paycheck, bank balance, and credits. And then this is the cluster vectors. Okay, 1, 2, 3, 3 clusters. If it's 1, then about the paycheck, it is in this center. About the balance center is this, and credit center is that. Same thing in the cluster 2 in this way. And cluster 3, third cluster, So paycheck here, which means cluster 2, for example, then those data has 0.18 clusters. Cluster 1 has about 1 paycheck each. This is about half paycheck. Bank balance, in this case, this is a center OID. Remember that last week I explained the center means it could be an average or mode, medians, frequencies. So it depends, right? In this case, average. So credit, same thing. Credit scores, those who fall in the cluster 1 have credit over 700. And this is those. So first record falls into the cluster 1, second one falls into cluster 1, third one falls into cluster 3, and cluster 2 according to those factors. Okay, so so if you see here, the first one in the first cluster, paycheck average is about 1 paycheck. If you see this, about 1 paycheck. Bank balance 180,000. So this guy is specifically 110, and then credit scores is 7. The average is 703, but this guy has a 720, and so on and so forth. This has been plotted. I think it is plotted. Is this area? Okay. So that is a plot to the 747. Yeah, just a few minutes ago. If you click this, three clusters. Uh, Three colors, about 3 colors that you can see. It's not really clear, but this depicted about the data. Okay. We can change this to, for example, hey, I want to make this 4 clusters instead of 3. So that this is the clustering based, this is the output of the 3 clusters. What if we make 4 clusters? So I am going to comment this so that we can see the space a little more. Is there anything that we, okay, I think this is. So we run this one more time. Okay, this is the cluster. Let me copy this and probably somewhere here. This is by 4 clusters. And a little bit above, this is by 3 clusters. Okay, so you may be able to see this, the first 2 data goes to the cluster 4 and cluster 3, 2, 1. So cluster 1 goes to cluster 4, most likely, right? Same thing here. That's what we can see. This is a cluster using all. We can do similar things using the Python, okay? So let me bring up the Python code. Okay. So this is a Python code. Read the CSV files. Okay. I'm using pandas, import panda. Panda is a very, very convenient data structure for data science. So we use pandas. So panda has the method very similar to the R method, read CSV files. And then training sets is only first 72, which means this guy doesn't care about the columns, only up to 72. This is yeah, 72nd. Those are the training sets. That's what we add here. And we're going to select only those 3 columns. So we call that training. K-means function takes the data training. That's this training. Okay. This K-means is a class name. It has a method called fit. This method, like a function, takes argument. Argument is the data. Okay. And then this class objects, there we say, hey, how many clusters that we want? If we want to make 3 clusters, then make 3, and then random states, initially 0 here. This is something that you enter randomly. And then print k-means labels and k-means cluster centers. That's what we have here. So I am going to highlight all. Okay, and then run. This is using the Python. Okay, Python a scientific kit learns packages, and there is a cluster. And the module is k-means. That's what we imported. Then this is the cluster that we found. This is the labels, okay? So from 0, so cluster 0, cluster 1, and cluster 2. So 3 clusters. That's what we assumed, the 3 clusters, right? And then cluster 2, cluster 0, 1, 2. Okay? So this is an average for the first element, first attribute, second attribute, and third attributes. Okay, this is a negative 1 exponent negative 1, which means that this is 0.9. This is 0.2. This is 1.1. If we see some of those cluster center, it's not exactly the same, right? Because it's a different language here. So, but anyway, we see this is using all. Yeah, this is using Python. So first two records and third and fourth. If we see, let's say, first five records, then first six records, first two and last two are in the same cluster. In this case, the first two and then next two are in the same, and then the last two in the different clusters. So it's a little bit different, right? Not exactly the same. It depends on the algorithms. So in this way, you can see which one that you want to use. Okay. Not only that, uh, because we can make a different number of clusters, we do not know which number is the optimal, which number is the best, right? So that is another issue. Although we have very nice algorithms, K-means algorithms, but if we have multiple dimensions, so why we have this much different between this R and Python? That's because we looked at the three attributes together. If we look at only one attribute, one number, then it should be much closer uh, outcomes. But in this case, a little different, right? Because we are considering three uh, attributes. If we consider, for example, 6, 7, 8, then it is almost impossible. Impossible means meaningless, even if we have clusterings. If we consider 7 or more attributes, then uh, then clustering is really, really meaningless. For example, if we cluster the people, okay, persons, then it depends on who clusters. Somebody cluster the people by skin color, somebody cluster people by hairstyles or uh, mother tongue or based upon their GPA or major. Each one is different. If we include all of those attributes into the consideration, then that much um, diverse, uh, that much diversity in outcomes. Okay, that is what it is actually. Okay, so number of clusters, that is the issue. If you stick to one specific, let's say this, if you stick to a limited number of attributes, fine, because that's a fixed. And the next one is how many clusters that you want to achieve. Basically, clustering algorithm doesn't care, doesn't assume initially how many, right? So we can tweak the clusters, 2 clusters, 5 clusters, 20 clusters, 35 clusters. So by having those clusters, different number of clusters, we may be able to see a very nice and reasonable clustering. The basic idea is this: all the elements within the same cluster should minimize the distance among themselves. And then any two elements each which are from the different clusters should be apart, should be should be in the long distance. Should not be the closer distance. That is the ideal. So you can implement that using another coding. Okay, like this Python, then you can make another one level global the functions. You can make this a one function, and you can change it, the number of the clusters, and then you can evaluate each clusters. What is the maximum distance among distance element in the same cluster? What is the distance between clusters? So you need to minimize the distance within the cluster, maximize among the clusters. That way you can find out, hey, this isn't the optimal number of clusters. Okay. I think this is my comments on hands-on that we did